Hello, everyone. Welcome back. I hope you enjoyed your lunch. This morning, between sessions, between the breakfast session and the first panel, I went up to my room and I was writing up my Forbes column for the week. I have my weekly column on Forbes.com, and as I was writing it, I was thinking, oh yeah, I'm going to get a lot of hate mail for this one. And it got me thinking that, just reflecting on the fact that I know how good a column is, by and large, by the amount of hate mail I receive. And I think we're all kind of in that mode where we get that. Now, sure, once in a while I write a column, and as I start to write it, I say, I'm just going to stick the knife in a little bit and make this a column that's designed to get people angry at me. But more often than not, the hate mail that I receive, when I get a large volume of hate mail, it's because I've really nailed them on the science. And it's not me, it's basically presenting what the speakers at this conference have been publishing on their websites and the peer-reviewed literature, etc. But when you, and then me channeling your work, when we nail them on the science, that's when they lose their minds. That's when I get the most hate mail. And I was thinking about that because just a couple months ago, I remember going on to Anthony Watts's website and seeing where he had written up about a new book that had been published in Germany, The Cold Sun, and seeing the reports that Anthony was writing up about it in Germany, about how the environmental activists were just losing their minds, all the attacks on this book. And it was in the realm of, once again, when you present the science well, when you really nail them on the facts that they're trying to convey and showing where they're wrong, that's when you get the strongest resistance. And I was thinking of that this morning because our lunch speaker, we're very honored to have a speaker who is the author of that book, The Cold Sun, who has experienced himself the vitriol from the alarmists, which just proves how on target the book is. And not just in terms of the book itself and how it nails it on the issues, but also the two authors. We have our keynote speaker here, as well as his co-author, who was one of the founders of the modern green movement in Germany. So when we have people that have bought into much of what the alarmists try to preach on a daily basis, but then take a look at the facts a little more and say this global warming message that the United Nations is trying to present, the alarmist message, just doesn't work out, well, then you've really stuck in the knife and gotten to the core of their misinformation and their outright lies. And that being said, I'd like to introduce our speaker. Dr. Sebastian Luning holds a doctorate in geology, paleontology, and has been working for 20 years on the reconstruction of natural ecological changes of the geological past. After research at the universities of Wales, London, Manchester, and Bremen, he took on a visiting professorship at the University of Vienna in 2005-2006. Together with Professor Fritz Varenholt, who co-authored The Cold Sun with him, he did co-author the book The Cold Sun, which was published in Germany in February 2012 and highlights the important role of natural climate cycles in past and current climate change. There is currently planning for a translation of the book into English. We are very much looking forward to that. And also they post on their daily blog a review of the new scientific papers and other developments in the global warming climate change discussion. It's my pleasure to introduce to you Dr. Sebastian Luning.
Yeah, thank you very much, James, for this very nice introduction and the invitation. I'm very happy to speak here at this prestigious conference. So first I pick up my thing here. Yeah, so as James already mentioned, we have done a book, and this is why I'm here. The climate issue is a very international one. Probably in a lot of countries, we all face the same thing. There is uncertainty about the role of natural climate factors, and we have taken the time to really put together all the evidence, and we base that on a lot of other very good books and lots of papers. I think we have something like 800 references in that book, so I think all those who say it's an unscientific book, they should really look through the references. We're just compiling what's out there. Okay, that was the wrong button, was it? Yeah. This is the green one, isn't it? Okay, good. So this is how the book looks like. It's not an advertisement session here. It's just that you can see how it looks like. It came out in the week that was the coldest of last winter, so we were quite fortunate. Good planning, I would say. And James already said that my co-author is Fritz Farnhold. He is the CEO of a renewable energy company in Germany, and I'm a geologist. Okay. So, what were the reactions? Almost every media that exists in Germany or the German-speaking world reported on that book. And we have got some examples here. The climate establishment, of course, was very interested in this. Some even reported before the book even came out, so that was interesting. A lot of others criticized it on day one, so this good achievement to read 600 pages book in one or half a day. You still need half a day to write that criticism. That was good. So the nicest statements here were from Professor Mujib Latif. When reading the book as a scientist, my hair stands on end. This is a pseudo-scientific treatise, so my translation, but this is what he said in German, basically. There was Hartmut Grassel, the former director of the World Climate Research Program, and he said, well, I don't really want to comment on this rubbish. It's great, so probably he doesn't even have a copy of that book. And there was Professor Joachim Marotzke from the Hamburg Meteorology Institute, Max Planck. The book authors have read a lot but understood very little. So this probably was referring to the 700 references that we have. Right, but we also had some very good criticism, and this is all just selections. Just recently in April, we were chosen as a book tip of the week by a Swiss economy program on television, I believe. So that was good. And 2 weeks ago, there's a German daily newspaper, and the Sunday edition had a literature thing in it, and we were very nicely presented there, very positive. So that was also very, very nice. So we do get positive criticism as well. In the Hamburg newspaper, there was a statement. Cora Stephan, somebody once criticized the intellectual doldrums in Germany. What an irony that a wind energy manager of all people has to experience this lull. So my partner in this is a renewable guy, and he's also a good. He does a lot of wind power offshore. So the PM magazine, which is science magazine for the people, science is vulnerable to groupthink. Once a consensus has formed, it becomes hard to express doubts. This is particularly true in the politically sensitive climate sciences. The subject is too important for that it could be allowed to suppress opinions deviating from the alleged consensus. And this is why the climate discussion needs people like Farnhold and me, well, hopefully, yeah. So, and you, of course, yeah, and you all. So we do have a blog. It's in German, so for most of you it will not be that interesting. But we have sometimes we do have translations on notrickzone.com by Pierre Gosselin. So I recommend going to notrickzone.com, and sometimes we are even on WhatsApp with that. So I'm very happy about that we are allowed to write there as well. Right, so how did it all begin for me? I'm a geologist. My business is looking back into the past, identifying, or first looking and then identifying patterns, and then take them into the present and see if they are still there. So this is what geologists usually do. And I was actually in New York for the New York Marathon, and I was before that in a bookshop and was just looking for climate books in general, and I bumped into this here, Unstoppable Global Warming Every 1500 Years by Fred Singer. Great book, and Davis Avery. Fantastic. And this really aroused my interest. It was published a few years earlier, 2006, I understand, and was a bestseller, New York Times bestseller. So, okay, wrong button again. The 1500-year cycle. So this I could not really stop reading it, and I nearly missed my starting gun for the marathon, but I really kept on reading afterwards as well. So the basic story, I think, from the book was we do know a cycle, and here we see it for the ice ages, so the last, 50,000 years, something like that. And there is this nice sawtooth pattern, and then this is even modulated. When you then look at that more closely, you see a 1500-year cycle. It's exactly 1470 years long, and it's arranged in groups, and there is up to 10 degrees centigrade of temperature variation. They are called the Darmstadt-Oeschger cycles, and they're well known from the so-called Pleistocene, so the last ice age. Now I think one of the stories from the book was similar things do occur in the last 10,000 years, so after the Ice Age. Okay, so is that really the same? That was my question, and let's have a look. When you look at the solar variations, solar activity changes, and you do a frequency analysis, so you look what cycles are really in that primary solar signal based on, for example, isotopes, beryllium or carbon isotopes, you do see a couple of cycles, and one is the Hallstatt cycle, which is around 2,200 years or 2,300 years. Then there is a 1,000-year cycle, which is basically called eddy cycle these days, and there's a 500-year cycle and lots of others. You probably know them. So the problem now is there is no 1,500-year cycle in this primary solar signal, and that was used a lot in the sort of ICCC corner to say, well, forget about these cycles. They don't really mean anything. Oh, okay. And there was Stefan Rahmstorff in the past. He studied these Darmstadt-Oeschger cycles in the Pleistocene, so last 100,000 years or so. And he said, yes, they might be even solar-driven. And if you know Stefan Rahmstorff, he's a very strong supporter of the ICCC, even a lead author, I understand, of the last edition of the report. So that was interesting. So this man says there might be some solar signature. But as I said, no 1,500-year cycle here in the last 10,000 years. I bumped then into this paper. It was also referenced, of course, by Fred Singer and Dennis Avery. It's by Gerard Bond. They basically analyzed deep sea cores from the North Atlantic, and what they found is there were what they called millennial scale cycles. So cycles that went up and down with a period or cycle length of 1,000 to 2,500 years. And the question now is that the same as the Darmstadt-Oeschger cycles? A great paper. I can only recommend reading that, or at least looking at summaries of that. And what they did is they looked for ice-rafted debris, so little pieces of rock that were picked up by icebergs in the Arctic area. And this debris, of course, when the ice melts, when icebergs drift to the south, falls down to the floor of the sea. And during colder times, these icebergs, they get further to the south, and they had chosen sites from the south. So whenever there was a debris layer, they knew now this was cold. Yeah? And so debris means a cold phase. You do see in the lower right corner circled the areas that they studied. A study published in 2001, and this is actually what they found. To the top you have colder temperatures, and to the bottom warm, so quite the opposite around here in this chart. And the blue curve is actually the solar activity curve. It's based on, in this case, C14 as a proxy for the cosmic rays. Yeah? If you heard the talk by Nir Shaviv, you you may be familiar with the cosmic ray proxy for solar activity. And the black curve is a temperature based on those ice-rafted debris pieces. And do you see, this is really the same thing here. It's a high degree of synchronicity here. And it's really striking, and I find it really fascinating. And this, at the end, got me, and I said, well, if this now, for 10,000 years, or even 12 here, worked so well together, solar activity and temperature, and also the temperature range, basically, is 1 to 2 degrees centigrade, exactly what we've seen in the last 150 years. Now, this may mean something, I thought. Yeah? Okay. And this is what Fred Singer and Dennis Avery, of course, also found. Gerard Bond, he's a pioneer in this. Unfortunately, he passed away in 2005, so a great scientist, and he should really not be forgotten, and his work is really the basis for a lot of things that we know today. He used to work for the Lamont-Doherty Earth Observatory in Palisades, New York, so very prestigious institution. And what has he done since 2001? In 2003, he was in a team analyzing also the temperature, basically, and other climate factors in a lake in Alaska. So this is a study here, Hu et al. 2003, and they found in the lower right, you see it, the same cyclicity, same timing, yeah, and again in synchronous to the solar activity. Great finding. So it's not just in the North Atlantic, it's also in the Alaska. And so when I started with climate a few years ago, I visited the blog by Stefan Rahmstorff here in the lower right corner. And so I was fairly new, and I just asked him, there is this great work you've done on the Darmstadt-Oeschger cycles. Don't we have the same thing in the last 10,000 years? And he said, well, no, I don't think so. Yeah? And then I said, but there is a paper by Bond et al., 2001. He showed that so nicely. And then he said, well, other scientists after Bond et al. Could not reproduce that. And by the way, in the end, he did not believe his own stuff. So he did not follow up on that, and he didn't think that he was right in the end. Yeah? So dead end street in climate science, he told me. Yeah? So this really got me more curious in the thing, and then I found that 2003 paper, which really just confirmed the 2001 paper. So what's the status here? What about he did not believe his own model in the end? Then I found here this paper, 2005, Bond again in the team. This is now in southern Germany, I think, a lake, and they found the same. They found also cycles. This time it was not in the last 10,000 years, but the interglacial before, so similar setting. So Gerald Bond was actually still on that model, and he was still pursuing this, and then sadly he passed away. So what happened since then? Is there any confirmation from other parts of the world? And I'm just showing stuff here from the last few months, and there's many more. We have cited them, of course, in the book, and every month there's a new paper now coming out confirming these cycles worldwide. Here's an example from Australia, and often with the isotopes that are used, you are not sure whether it's precipitation or whether that's temperature. So often the authors go to the safe side and say it's precipitation. If you had another proxy that could pick up temperature, you would probably also see temperature changes. But now look at the cycles, and the timing is exactly the same. You do have this ups and downs, and it is again very much in synchronicity with the North Atlantic cold periods. It's really fascinating. I think here the numbers are the layers, the debris layers by Gerard Bond. So this is Australia. This paper now is from February 2012 in Paleoceanography, all very respected peer-reviewed journals. Cape Hatteras, North Carolina. You see the cyclicity here. great thing. So temperatures in this case and solar activity are in synchronicity and also parallel to the North Atlantic study from 2001. In April 2012 in PNAS, here from this country, a Chinese cave, and see, have a look at the graph. Again, a very nice cyclicity, solar activity, and climate in delta 18.0, in this case, all in sync. So, I mean, this is very convincing to me, at least. Right, and here, this is an older paper, 2001, in Oman cave. At the top, you see the cosmic rays as a measure of solar activity. At the base temperature, I mean, there is a certain degree of synchronicity, I guess, here. So these things are all forgotten, and they don't seem to matter at all to the IPCC. And we are not talking about tens of degrees of change. We are talking about 1 or 2, sometimes maybe even 3 degrees. So this is really something that matters. Right, and this I think we know very well. Bob Carter has this. This is from the Greenland ice core deuterium reconstruction, I believe. And you see again, there is now this cyclicity for the last few thousand years again. Okay, and I don't want to bother you too much with more details. There is many more. We have put together a few here, and the if you can see the dark lines here, these are the cold periods in sync with the North Atlantic cool periods. And on the right, you see all those countries. There is also more China, more India, West Virginia. So it's really something which, me as a geologist, which convinces me a lot. Okay. Now, so how can this actually be? It's a big miracle, because when we look at the IPCC radiative forcing, the sun here is very much down there. Yeah, you see it has a 0.12 watts per square meters, whereas the CO2 at the top here of that chart has 10 times more. So how can that be? With this radiative forcing, there's no chance to explain the past. So what we are actually dealing with is the present-day models used by the IPCC cannot explain the past, and no modeling will really get those results that are proven by the geological record. It's a big miracle. What could be the solution? Wow. Now let's just concentrate on the last 10,000 years, on the last 1,000 years, because we now have to really think, what does it mean for our climate change today? And what I really want to suggest, and what Fred Singer and Dennis Avery have suggested, it's part of this cyclicity, and one can then debate how much of anthropogenic CO2 effect is on top of that. But essentially, the pattern is a natural pattern. It's exactly what we expect. So, we have here the last 3,000 years, in fact, and I've just, in a very schematic way, put the solar activity here. So in this case, it's every 1,000 years, so this eddy cycle, we called it. It's going up and down. And the temperature is going up and down. Yeah? So this is what we can see. And I have cut this graph on the right margin at 1850. So this is just the pre-industrial area. So this is the normal, natural pattern. And we see there's a cold period, 1500 before Christ, and we have all sorts of warm phases and cold phases, and a lot of them have names, the Minoan warm period, Roman warm period, medieval warm periods, and the respective cold periods, with a little ice age being the last one. So, and what did CO2 do? Well, not very much, as far as we know. So, what could be the driver of this temperature cyclicity? Okay, now comes 1815. People start burning coal, whatever. And what would we have expected? The cycle would have gone up, as shown here. The temperature would have gone up. This would be the natural continuation of this cyclicity. And just, is it a coincidence now that CO2 goes up? Well, now I think what needs to be proven is that CO2 has an effect, because the sun has proven itself 10,000 years that it can drive temperature. So this is the situation as it looks like for me, okay? Yeah, so people, of course, did not like this temperature cyclicity. So they made an effort to really smooth out the temperature history. You know that story. Michael Mann tried some tricks, and Steve McIntyre and his partners tried to debunk that and manage that, to do that. So this is how this chart would look like with the hockey stick. Yeah? But even if you smooth out the medieval warm time and the Little Ice Age, there's still the other 9 cold phases before that. So do you also, how do you get rid of those? This is a big question. Yeah? Okay, so this, I think, failed. Yeah? And, but, of course, something needs to be done. I think that's also realized by the IPCC, that hockey stick is out, it's over, need new ideas. Yeah? So new idea is volcanoes. Yeah? So the Little Ice Age, of course, it's there, it's global. And how was it formed? It can't be the sun as we've seen because the radiative forcing is too small, so it has to be volcanoes, clear. And yeah, so what's done is they just throw in a volcano, and with the reconstructions they now start after the medieval warm time, yeah, because this is still hard to explain with a volcano. But again, then you have to have a volcano here, and a volcano here, and a volcano here, and it's all just coincidence that the sun was very weak during these times. A lot of coincidences here. Great stuff. Yeah. So not a firm believer in the volcano theory here. Good. Well, this is the real data. Just wanted to show you. Of course, when you plot it in real data, it's much more rough, and but we don't expect that it's as smooth. But you see very nicely the Little Ice Age here and temperature at the base. It's a nice downward bend, and also the solar irradiance here is down. Okay, so we're really talking about these last 150 years, and this is, as I said, just a continuation of that cycle for me. And yeah, this is the last 150 years. Temperature was going up by nearly 1 degree centigrade. CO2 was going up, as we know, and sun was going up. And this is always forgotten. The solar magnetic field, as a measure for solar activity, has doubled in the last 100 years. You will really very rarely hear this in the debates. Okay, and something that is also forgotten is in 2004, there was a paper here in Nature by Sami Solanki and colleagues, and what they wrote is, in the last few decades, this was among the highest solar activity in the last 10,000 years. So is that coincidence? Yeah, don't know. Probably yes. No, probably not. For me, it's not a coincidence because this is really the key source for heating the temperature, and I just see that pattern, and that all fits so well together. Just to show that the sun does affect climate, here the last 100 years of the Paraná River, second biggest stream in South America. In blue, you have got the stream flow of that river, and the sunspot number in red. Fits quite well. So apparently the hydrological cycle can be influenced by the sun. Yeah? And yeah, now we have a look at the 11-year cycle. So this one, the shortest cycle. And the thing, of course, is always 0.1 degree change only in the total solar irradiance. That's fine. It would not have a big effect. But we really have to look for a solar amplifier, and there's Henrik Svensmark and there's Joanna Haig. They all look for amplifiers these days, UV, ultraviolet, or cosmic rays, or other ideas. And when you look at the cosmic rays here over the 11-year cycles, that changes by 10%. So this is much more effective if you have a good physical mechanism. And also the ultraviolet changes several percent, and in certain ranges also up to 70%. Yeah, right. And another nice example I bumped into, this is the Lake Victoria in East Africa. And here, for long stretches of time, you see the lake level going up and down in sync with the 11-year solar cycle. So that's quite interesting. And in the middle, there's other factors probably influencing that. And if you look closely, this is from Nicolas Gaffetta, you can even find that 11-year cycle in the temperature, but you have to get rid of all the El Niños and other effects. Okay, so what's next for the bond cycle? And I'm nearly done here. As you know, the greatest part of solar physicists say that we are now expecting in the next few decades a slump, a decrease of solar activity. If solar activity played a role in the past in the climate change, then it should also play, I think, a role in the upcoming years. And we have already seen that cycle 24 is only half as strong as the previous cycle, so this decrease has already begun. And now let's have a look how this all fits with the cycles. Of course, when you take the cycles to a certain extent, you can make predictions. And here we are dealing with the Gleisberg and Soester-Fries cycles, 87 and 210 years. And basically, this is something from Abdul Samatov from Russia, 2010, but there's other reconstructions which fit very nicely, and he already predicted that this decrease takes place. And this will probably bring a couple of tenths of degrees of cooling. And if we have a strong sun and we also have the warming of the last 150 years associated to a large degree to the sun, I think we have to reduce the CO2 climate sensitivity. And therefore, we, in our book, also predict that temperature probably will go down a few tenths of a degree until 2040. And so this will be very interesting to watch. This is by Mark Kluivert, a similar prediction based on these cyclicities. And there are, of course, IPCC people who already say, well, yes, the sun is going down, but it has no effect. Why should it not have any effect if in the past it had such great effects? This is really hard to understand. There's German groups, there's here English groups, and with this slide, I think I conclude this is a very schematic prognosis. The red lines, those are the IPCC lines with warming up to something like 4 degrees compared to today. And we still allowed a certain amount of warming to be caused by CO2. So this would be sort of a maximum scenario from the geological point of view. Everything is possible from 0 to probably 1.5 degree warming per CO2 doubling. So our prognosis is we will have much less warming, and so we have much more time really to work with renewable energy and do it in a sound and not so destructive way. With this slide, I say thank you very much for your attention, and thanks again.
We have time for questions and answers, so I will turn it over. Taylor's already out there. Fantastic.
Hi, I'm Bill Gray from Colorado State. I've been looking at weather a lot of years, and a very nice talk, very wonderful slides and things. But I think you've emphasized the importance of the sun too much. Okay. This is a classical subject that's gone back for hundreds of years. Everybody overemphasizes the sun, in my view. Now, the problem is your variations of the solar effect are so small. What did you list, 0.12 or watts per square meter? That's too small to affect things. I have a very different idea, and a lot of my colleagues do too, that the driver on the climate, I agree, there are these rough 15,000-year cycles, 1,500, 2,000, the bond things. But there are internal mechanisms that cause climate change. Not the volcanoes, yes, that may work a little bit for a year or two, but there are ocean circulation changes that operate on these 1,000-year times or 1 to 2,000 year time scales, and also multi-decadal variations. And much of this variation of the ocean that I feel is a primary driver is due to salinity variations, natural salinity variations. And I've been following this for many years, the solar effect. They've been having meetings and talking and all this, but I think you're right, there's something there. There's something in the solar. I don't discount the whole thing, but it's small and is not the major driver.
Yeah, thank you very much, Bill. Yeah, I will comment. Of course, I will comment. No, thank you very much. And I think we fully agree that internal cycles do play a great role, and they have been underestimated also by the IPCC. And I think here especially about the 60-year cycles, so the PDO, Pacific Decadal Oscillation, and the AMO, which are related. That's right. And especially the warming 1977 to 2000, this is basically the upswing of the PDO, and the AMO came shortly afterwards. So a lot of that really, of that warming is that PDO cycle. But yeah, I have to disagree, of course, on the impact of the sun, because we do see in the last 10,000 years this excellent coupling, this synchronicity of sun and temperature. And we are talking about several degrees here. And you're right, with the TSI, the total solar irradiation, you cannot explain it. But that does really play no role in this, I guess. I think the cosmic ray model might play a very significant part in this. And so via the clouds. Or maybe even in combination, the ultraviolet, with the stratosphere and then that heat. In the stratosphere, we actually see several degrees of changes with every solar cycle. And if you find a mechanism to transfer that down to the Earth's surface, you're fine. But whatever this solar amplifier is, we do need one, because we cannot explain the past if we don't have a solar amplifier. But on top of that, and you're absolutely right, there are internal cycles which have to be added, and there's volcanoes coming in from time to time, but they usually only have an effect for a few years, so don't know how the little ice age for 200, 300 years can be explained by a few volcanoes. So it's always a mix, and I fully agree, internal cycles do play a role.
Before the next question, can I make a suggestion? Let's get Roy Spencer and Willie Soon up here. We'll have a steel cage death match. We'll have Bill Gray, Roy Spencer, Dr. Luning, Willie Soon, and then, of course, but no, really, isn't this the beauty of what we have here, in the sense that we can have different theories that all of which show that carbon dioxide is not the primary driver, and we don't have to have some orthodoxy where we're beating each other over, getting personal. Bill Gray sending death threats to Dr. Luning. It's a wonderful thing.
I hope we're still friends. Yep.
Just the type of exchange that's not going on out in the climate world. There's one side, there's the other. The question is, you say, yes, you can't. There's got to be an amplifier there. What's that amplifier? And why did we have for centuries the term solar constant?
Yeah, that was a question. Yeah, so solar constant obviously is wrong. Yeah, it's just historical, and yeah, we do need this discussion. And I think I'm from the geology, originally from the non-climate science, and I'm just used to very controversial discussion. And once you had this discussion, afterwards you just go to a pub and drink a beer. So this is, I think, what should be science about. Yeah?
Well, Sebastian, can I thank you for coming and giving us that wonderful presentation? I, for one, am convinced. I think the correlation you showed us, both over the long term, but also the individual cases, the river and so on, they cannot be explained by any other than a causal relationship. And unlike Al Gore's comparison of carbon dioxide with temperature, he got cause and effect confused. In your case, there is no question of getting cause and effect confused, because I don't think the flow in the river in South America is going to affect solar activity very much. I have been saying in the course of this debate again and again, my key phrase has been, the warming we have seen simply represents a continuation of well-established natural climate cycles, and you have proved that case, and I'm delighted. I'm also delighted that you and Fritz Fahrenholt are coming to the European Parliament next month, I think it is. We look forward to making you welcome, and my question, for what it's worth, is how soon can I have a copy in English, please?
Yeah, but thank you very much for those nice words. Yes, the book has been translated as of 1st January, and for the last 5 months we were talking to publishers, so I hope we will resolve that very soon. And the advantage is the pictures are in color, so this hopefully will help with the understanding. Maybe a lot of things you will already know which are in the book, but it's especially this part which I think is very important and needs to be stressed much more.
You cited volcanoes may precipitate an ice age or cycle. Has anybody done research on mercury cycles in samples? Because a large volcanic explosion puts a lot of mercury in the air, so I got a spike in mercury every time one of these occurs.
Yeah, there have been studies, of course. Recently there were papers that suggested that the little ice age was caused by volcanoes. And when you look closely, I think it was even Willis Eschenbach who looked at that, and then suddenly you find that the cooling happens before the volcano erupts in some cases. So, not so sure about that. And also you need really every other year a very strong volcano to do that cooling. And then some people took out their circulation models, so their theoretical toolbox, and they said, well, we have a scenario where this cooling is preserved over 100 years after that volcano broke out. Also not so sure about that, because today we see when the Pinatubo or so breaks out that it's just 2-3 years, and then that's it really. So all sorts of excuses, I think.
Yes, I'm Harold Dwaron, a mechanical engineer who has a lot of experience with analyzing vibrations and cycles and methods of doing that. And I've heard the almost debate between you and Dr. Gray. I think, there's a unifying theory somewhere. Part of the problem I see in climate science is where they define the boundary on the system, and defining what's forcing and what is response. And in your discussion, one could say, well, the sun is forcing things on Earth that maybe amplify. But one could also back up and say, well, the whole system is the solar system, and all the planets and the orbits of the planets are affecting perhaps sun activity and the distance of the Earth to the corona. So, and then one would say, well, the cosmic rays are outside of that system. So it depends on where you back up and draw the system boundaries as you determine what is forcing.
Yeah, it's a good point. One really has to be careful. Recently there was a paper trying to, in the last sort of few 100,000 years, that the CO2 was going up and down and temperature as well. And I think the most likely explanation is it's degassing out of the warming seawater. But recently there was a paper trying to prove the opposite. And it is something that is being debated. But in this case, I think it's really hard that the temperatures on Earth could influence solar activity. Because maybe gravity effects do play a role. There's Nicolas Gaffetta out there who writes about potential gravity effects, maybe even the 60-year cycle. For me, at the moment, it doesn't play any role what causes the solar activity changes. I see they are there, and I see the temperature has to react to them, because the other way around is, I think, not plausible. But in general, one has to really look what's cause, what is the effect. That's absolutely true.
Yeah, Stan Goldenberg, Hurricane Research Division. Excuse me, a really ignorant basic question on observations and temporal homogeneity of your observations. how do they get solar cycles back 5,000 years, 10,000 years? Maybe you already mentioned that, I missed it.
Yeah. No, I did not explain that in detail. It's basically isotopes, so it's beryllium and it's carbon isotopes, and they are produced together with the cosmic rays, and the cosmic rays are modulated by the solar magnetic field, to make it a bit complicated, but the solar magnetic field actually controls how much of the cosmic rays that come out from outer space, how much come to the Earth, and the solar magnetic field is shielding the Earth basically, and the stronger the sun, the fewer cosmic rays come to our Earth, and this we can then measure in ice cores or in tree rings or whatever.
Climatologist.
Oops.
One of the things that strikes me as very interesting about secular climate change, and I'm sure you know this, is that looking at the two direct measurements that we have, namely satellite microwave and radiosondes. Radiosondes go back to about 1948, satellite microwave to late 1978. You see a drop in stratospheric temperature. Now, it's not smooth. It's a very odd behavior. The record appears to show that when a volcano goes off, the stratospheric temperature drops, and then it doesn't recover. And then another one goes off, and it drops another increment. Now, that's a very important, that stratospheric temperature is a very important component of the radiative balance of the atmosphere. Do you have any idea what's going on?
Yeah, well, actually, previously I thought maybe so the stratospheric temperatures have very little to do with it, but there was recently a paper by a Bulgarian researcher, Kili Farska, I think is her surname, and she actually brought up a third solar amplifier, and she went through the stratosphere, in fact, and through the ozone, and she had some very interesting correlations there. So it might in fact be that the stratospheric temperatures through ozone creation and decay, that this also plays a major role. So we have to really be open in the search of the solar amplifier. I still think that each of those candidates have a chance to at least contribute. It's maybe not a single amplifier we are looking for, maybe it's a combination. And this recent paper really showed that we have to do more research on that ozone stratospheric solar-driven driver, solar-driven amplifier.
Yes, Stan Littman. My background is in the fusion program. I was doing plasma physics diagnostics, the boundary plasma of the edge tokamak, which is very similar, 5 million degree plasma, to a solar flare. And my first paper in Astrophysical Journal was 25 years ago, where I measured the temperature of the solar flare at 5 million degrees. And as a boundary physicist, I would say that the stratosphere is probably, to me, it's my pet, is the underemphasis of the UV and X-rays in the stratosphere. But what I noticed as a plasma physicist is that the sun goes through these spikes very similar to the edge of a laboratory plasma edge. It goes through these spikes. Very similar, the patterns look very similar. So I think that's a big neglected area. That plasma physics, the solar dynamics, we don't understand the sun. That's the basic problem. If we have a better model of the sun, we could probably predict the future a lot better. I'm wondering why you neglect the fact that, why don't you look back past 100,000, Milankovitch cycle. The point is, are we overdue for an ice age? It seems to me that we are overdue for an ice age as the thing to fear. And what would you say about the longer term?
Yep. Yeah, those are scales which are much longer, and on purpose I left out sort of the Milankovitch cycles and longer for the 400 million year cycles. So there's other parameters coming in there. I just chose sort of solar activity for the last 10,000 years because Milankovitch has little to do with it, although the mid-Holocene climate optimum, of course, was one of these times, Milankovitch warming. You're right. One should also look at the eruptions of the sun, and one thing is the what's it called? So there is eruptions on the sun, and they suddenly create a very strong solar magnetic field, and then there were measurements. What do the clouds do? That was Svensmark and others, and they really saw that So fewer cosmic rays because of strong sun, and there were suddenly fewer clouds. No, let me think again. So there was a strong sun, fewer cosmic rays, fewer condensation nuclei for clouds. Yeah, and that means then fewer clouds. Yeah. So in fact, a strong sun gives fewer clouds, and with these four-bush events, they're called. Now I got it. Four-bush events. This is maybe also something to look at because they are such eruptions maybe you are referring to. And there's much more, I'm sure. Yeah.
Hi, I'm Tom Weissmuller. Was part of the NASA group here and also colderside.com. There's a possibility I can reconcile Dr. Gray and your analysis here in the sense that the increased wattage of absorption due to a stronger sun, since 78% of the Earth is ocean, and the oceans are being exposed to the sun 24/7, just half the Earth, the accumulated energy is accumulated. It's a linear accumulation. It's a small amount each year, but your cycles cover 1,000 years. And the small amount of increase, then the sun slightly decreases its intensity, then you have a slight subtraction every year. The ocean retains heat 1,000 times better than the atmosphere does. There's a huge lag in that boundary layer of heat transfer, and it does happen, and yes, you get albedo effects of a La Nina, but you need to see the wattage accumulation covering the Earth one small step at a time, and that can account for the total heat difference that you show in your graphic.
That's right, but would that be linked to solar activity in the long run? No? So, yeah, that's the accumulation theory. I think that's also out there on the market. And there is really so many things. And when you hear the science is settled, we don't need a solar amplifier. And you look at the past, you certainly need one. I think science, and that's taxpayers' money really paying those scientists, they should really look at all these options. Yeah.
Speaking of all these options. Doesn't sound. Okay. It seems to me that if you've got 5,000 or 10,000 years worth of data about tree rings, or about sun cycles, or about this or that or whatever, you could take every one of those time series, Fourier transform, and get a whole bunch of spikes of frequencies. At this point, you take the various different ones and lay them against each other, doing a correlation, and you could find that, aha, this pair is well correlated, this other pair is not so well, this other pair not at all. And in this way, you could narrow the field of important things to care about, and you'd be analyzing probably 20 possible different natural causes and finding out which ones are likely to be important.
Actually, this has been done in some studies already, and the frequency analysis showed that it is the Hallstatt cycle and the Eddy cycle, so the 2,300 and the 1,000-year cycle plus the others. So, and the same came out of the primary solar signal based on those isotopes. Yeah? So I think the fingerprint is very clear. It is those solar cycles in both data sets, and therefore the key driver, there's lots of others, seems to be the sun, also based on that fingerprinting and frequency analysis.
All right, well, that'll do it for questions. Thank you so much, Dr. Mooning.